Hi, everybody. Today what we're going to work through, you can see the title up at the top, we're going to address linear inequalities. And so I've got a question that I've got on the screen here for you, and all I'd like you to do is just go through and answer that problem. Okay, no intro, no anything else. You guys work your way through, answer that question for me. Okay, pause the video now, give it a shot. Okay, we're back. So it may have seemed like a bit of a weird question, and I want to be honest with you, we're not really even going to solve this problem today. This will be one where you can go back and solve it if you wish. I'm just hoping that to some extent we recognize that we had something underneath a root. The question asked us for when is it defined, and we know that to define that value we have to be able to calculate it, and we know that we can't have negatives underneath our root. And so that's what drove us to be able to say then that we know that 4x minus 2 has to be a positive number or 0 for that expression to be defined. So whatever's underneath, it's got to be 0, it's got to be positive. So 4x minus 2 has to be greater than or equal to 0. I honestly don't even care what you got for your answer. As I said, we're not even going to solve the problem. But what I do want to draw to your attention is that brings up an issue for us that we're going to end up getting into dealing with inequalities. So as we work our way through, really what we're going to get back into is the idea that we've got greater than, less than symbols. We've also got greater than equal to, less than equal to, if I'm assuming that I'm always reading left to right. That what we're going to get into today is what you see in green. And we're going to talk about how do we solve an inequality, not an equation, but an inequality. And do we have an algebraic means to be able to go through? We're also going to address a little bit of graphing these and what that might look like. Today is going to be a fairly straightforward day for us. It's going to be an awful lot of review with a couple little concepts thrown in. So it should be a good one to get into this next section of topics. Okay, let's jump into it a little bit then. What you see on the screen, there are two inequalities. And you can recognize those because you see the inequality symbols in each equation or inequation. So what I'd like us to do is to go through solve and graph. Now, we're not going to graph these problems right off the bat. So what I'm going to ask you to do is before we jump into the next section, I want you to leave a few lines. I'm going to remind you about this later on, but I just want you to leave a few lines blank underneath. Okay, let's jump in and let's tackle problem A. Now, this is brand new to us, so we don't really have a whole lot of background to deal with it. What I'm going to ask you to do is I want you to solve that as if it was an equation. Okay, I want you to solve it as if it was an equation. So I want you to imagine, not write down, but imagine that that was an equal symbol between the 4 and the 5 and not that inequality symbol. Okay, again, we're not going to write it down, we're just going to think it. And I'd like you to go through and solve. Okay, pause the video now. Okay, we should be back. And this is what I would have expected to see. Get rid of a minus 4 means you have to add 4. To get rid of a times by 3 means you divide by 3. And hopefully we got down to an x is greater than 3. Now, I don't know how confident we feel in that, but what I want us to take a look at is the ability to check our solution now. So, this is not like an equation, where when you solve an equation, you solve for a specific x value or variable value. I'll just generically call that x. It could be multiple values, but they are very specific. Grade 9, you solve for one value, sometimes 2. Grade 10, you solve for 2 values an awful lot of the time. What we're solving for, what we solved for was a range of values, a span of values. It's actually like an interval of values. x is greater than 3 is an unlimited interval of values. It gives me this huge range of values. Any possible number that is greater than 3, it says would satisfy that inequality. So what we do then to check it is we go through and we're going to check a value that satisfies that interval. So what I'd like you to do is just pick the easiest value that is greater than 3. Now, I would hope that everybody had the number 4 in mind. So let's check 4. That's the smallest integer greater than 3. So what I'm going to do is I'm going to sub that in, and I'm going to do my good old left side, right side check that we addressed way back in grade 9. So I can sub in a 4 on my left side and sub in a 4 on my right side. Well, there was nowhere to sub it in, so it's just 5. And now I can calculate. Okay, so 3 times 4, that's 12. 12 minus. And now I look back at my inequality. It says that my left side should be greater than my right side. Is that confirmed? Yes, so I know I'm good. Or do I? See, one of the issues becomes, because it's not just a specific x value, but a range of x values, maybe I just chose an x value that happened to work. I shouldn't necessarily have exact 100% confidence that I know I'm right in x is greater than 3. So what we can do then is we can now check a value that falls out of that range. So what I'm going to ask you to do is now pick the easiest value to work with that would fall out of that range. So my range is x has to be greater than 3, so you pick the easiest value to work with that would be less than 3. Now, I'm going to bet and say I would have a ton of people that would say, well, then how about I go 2? And I would sub in 2. However, I might argue to you that x equals 0 is going to be the one that fits in that interval that is easier to work with. Now, why would I not use x equals 0 in this instance? Just because it's too far away from this key value of 3. Like really what I want to be is a little bit on one side and a little bit on the other side of it so that I can kind of narrow down that yes, it was 3 that was the key value for my range. So I'm hoping that a bunch of people would have used 2. I would use 2 to check. And now I can do the exact same thing. I don't need to blindly write in my 2. That's 3 times 2 minus 4. That's 2. My right side is 5. And my original inequality says that my left side has to be greater than my right side. And that is not the case. And so once you take a look at both the green and the blue, now I can have an awful lot of confidence that my solution of x is greater than 3 is correct. The value I picked that just barely gets into that range, that interval, did satisfy it. The value I picked that was just outside the interval did not satisfy it. I feel pretty confident that x greater than 3 is my solution. Okay, I just want you to stop for a second, and before we think that what we just did was difficult, I just want you to think back. Look at your solution. Did you come up with x is greater than 3? Probably. In fact, I would be surprised if you didn't. So the first thing I want you to notice, is it difficult for us to solve linear inequalities? No, like you did that. You just treated your inequality symbol as if it was an equal sign. Everything that we did in the green and the blue, that was just a check. So that didn't require us to do that. We were done with just the red. So if I was to give you that problem, all you'd ever have to show me is the red. Okay, now within your notes, if you're going to put B directly underneath A, leave, I'm going to say about 3 lines blank. If it's going to look like your screen looks and question B is up on the side, then we're still going to leave some space But I wouldn't worry yet about how much space we keep until we get to problem C, let's say. Okay, what I'd like you to do now is do the exact same thing with B. I want you to imagine that your inequality symbol is like an equal sign, and I'd like you to go through and solve that. Okay, pause the video now, get a solution for B. Okay, we're back. So, maybe I end up doing this. Sorry. And to get rid of that positive 3, I'm going to subtract 3. And now, to get rid of my times by negative 4, I'm going to divide by negative 4, and I come in there. Pretty straightforward. Okay, now what I'd like you to do, let's do a check. So I'm going to do my green check. I'm going to pick a value that fits in that interval. X is greater than or equal to negative 1. Now, the one piece of guidance that I need to give you, don't choose negative 1. Now, I understand that that happens to fit in that interval because we see that it has the equal sign. Here's the problem. Like, what if I goofed up and it wasn't supposed to be that? What if it was supposed to be like less than? What if it wasn't supposed to be 1 at all? Maybe us picking negative 1, since it's right on the margin of whether I do include it or not, isn't a good choice. So, pick the next easiest value that fits in that interval. And so if I have to pick x is greater than or equal to negative 1, then my next integer that fits in that interval is 0. So let's go ahead and check 0. 0 should work. On my left side, I'm going to get 3 minus 4 times 0, which is 3. On my right side, I'm going to get 7. I take a look back. Oh no. Like what that says is my left side should be greater than or equal to my right side, and 3 is not greater than or equal to 7. No. So I have a problem with that. And I made a mistake somewhere. Okay, so what I'm going to do is I'm just going to get rid of that. And I'm going to maybe solve that a different way. Because I'm going to bet that I have some people who don't solve linear equations with their variable on the left side. That isn't their main focus. But instead, they like to solve equations by making the coefficient positive. Like I could have had some people that didn't like having that negative 4 on the left side. And so instead they said, well, I'm going to get rid of that minus 4x. And so I'm going to add 4x. Well, then at the same time, they're going to get rid of that 7. And so they're going to subtract 7. 3 minus 7. And now to get rid of my times by 4, I divide by 4. And I get something like that. Okay, I want you to take a look at both of those statements because you can maybe see that I have two different answers written in red. Now, when we read that first statement, we see x is greater than or equal to negative 1. And I would hope that when we read this next statement, we do not read it as negative 1 is greater than or equal to x. That there's actually a common practice that's followed. And I want to make sure we pick this up as soon as possible. Whenever we read an inequality, we always read it variable out. So when you take a look at that second solution, we should be reading it from the right to the left. And so when we read that, you're going to notice that's actually not a greater than or equal to symbol at all. Notice the direction that we read it matters. Now we would say x is less than or equal to negative 1. So we can clearly rearrange that for anybody who wants to look at that and say, oh, well, I don't really like having to rearrange the way that I write it. I'll be honest with you, if I was to solve that, I get kind of lazy. Now, the weird part is my lazy actually requires more work. that I would now write that way to be able to say my x is less than or equal to negative 4 divided by 4, because I speak English and I like to read left to right. Okay, now that you can see both of those forms, notice we actually have two different answers. That in the first solution, we solved and we got x is greater than or equal to negative 1. The second one, we got x is less than or equal to negative 1. But we feel like we did the same thing in both. We treated both as if they were an equation. And you did. The problem is you can't treat inequalities like they're an equation. Always. That there's actually one adjustment that we need to make sure that we're good with. Now, which of those two is correct? Well, we clearly saw that the first one wasn't correct. So I'm going to check the second solution just in blue. Or sorry, I'm going to do that in purple. I don't want to make any confusion over we're checking the anti-solution. So what I'm going to do now is I'm going to pick an x value that is less than or equal to negative 1. I'm going to pick negative 2. And I'm checking it in our second solution. Okay, so my left side, way up in my original, is 3 minus 4 times negative 2, so plus 8, that's 11. My right side is 7. Yep, my left side is greater than or equal to my right side. I know that I'm good. So that second solution starts to feel better. Okay, I still don't know for certain until I check for my ante, the opposite case. So now what I'm going to do is I'm going to sub in my easiest value that doesn't work, x equals 0, and you can already see that we've done that in green. We can see that my x equals 0 doesn't make it work, and so now I feel really confident about my second solution. Okay, so how can we be aware then of when can I treat it as if it is like an equation and when can't I? Well, it just requires one little adjustment for us. We're going to get this down in our notes in a moment, so I wouldn't worry about copying down what I'm saying right now. Let's just make sure that we get down our solution. This is the key point, and my mistake was made right here. I actually did an operation from my first red line in that first solution. I said, well, to get rid of a times by negative 4, I'm going to divide by negative 4. So what I'm going to do is I'm just going to actually put that line in. And so when I did that, I got a 1. It happened to be negative. And it was negative because I divided by a negative number. And we need to remember a little rule with inequalities. That every time I divide or multiply by a negative number, I have to change the sign of my inequality. Now, that is brand new to us. And it's a little bit of a rule that you just have to remember. Put it in your brain. As I said, don't write it down yet. We're going to formally get it down. Now, it should beg the question, why do I do that though? It's not just a rule I blindly memorize, but why do I do that? Okay, I'm going to put down a very quick example, just so we can kind of see. Are we all good if I write down that 3 is greater than 2 as a true statement? I hope that we're good. So I want you to see, I'm going to treat that as if that was an equation. And I'm going to do the same operation to both sides. I am going to multiply or divide both sides, doesn't matter, by negative 1. And if I divide both sides by negative 1, I hope you see that I actually created an incorrect statement. Now I have that negative 3 is greater than negative 2. That's not true. But if I switch the sign of the inequality, now it is. Negative 3 is less than negative 2 because negative 3 is further to the left on our number line, and further to the left is a lesser value. Okay, maybe you might then see why we have to do what we do and where it comes from. It's still a rule that you're going to have to remember. As you work your way through to solve, you're going to have to go, oh, I divided by negative. Got to make sure I switch the signs. But you can maybe see in green why it's the case. I'm just going to erase that green, and I'm actually going to draw a good old number line. On that number line, that might be my 0. I'll just put that like kind of in the middle. I would then have 2 somewhere over here and 3 somewhere over here. Well, if I went and I multiplied or divided, let's say by the easiest negative number, by -1, I'm going to change 2 to a -2, and I'm going to change 3 to a -3. I want you to notice that what I did was I took 2 values that had a relative place. 3 is greater than 2 because 3 is further to the right than 2 on our number line. But anytime I multiply that by a negative, I am reflecting that to the other side of my number line. And so anything that was further to the right is going to become further to the left after that reflection. And if it is further to the left, then any greater thans would have to become less thans, and any less thans would have to become greater thans. So anytime I do a multiplication, division by a negative number, I need to make sure I switch the sign of the inequality. Okay, now that we can see why, let's make sure we get that down. I'm just going to make sure that I get rid of all of that theory. So, below both of your answers to A and B, or in some good spot, again, just leaving a little bit of space for us to put down the graph portion of that problem, can we get down our chunk of theory? So, we've already explained why. Let's just get down that rule for us that we need to make sure that we recall. If both sides of an inequality are multiplied or divided by a negative number, the sign of the inequality must be reversed. We got to change it. Once we have that down, now I want to go back and I want to address what the whole graph part of this question looks like. We might have read the graph part and went, oh no, now we got to do like an x-axis, y-axis, and so. No, it's not that complicated. Okay, so we should have 3 lines of space still with problem A, and we should still have 3 lines of space with problem B. Okay, let's jump back in and address those 2 problems. Okay, so what you see now on the screen would be the solutions I would expect to see for both A and B. Obviously in B, I've put down both solutions. You could give me either one. But now what I want to do is I want to address specifically this whole graph part. So what do we mean when we say we graph the solution to an inequality? What we're going to do is we're going to graph what that interval of values looks like, which means we're going and we're dealing with a number of values. So in the first A, on some of those 3 lines, what we're going to do is we're going to put down a little number line. Now, on that number line, there's a particular process that we follow to be able to graph that. We don't put 0 down in the middle. Like, I just want you to imagine, like, what if your solution to that was like x is greater than 1,000,000? Like, you don't want 0 on there. We don't care where 0 is. That what we're focused in on is the key value. So that solution was x is greater than 3. That means we put 3 right in the middle. Now what we need to do is we need to highlight all the values that fall into the interval of x is greater than 3. It doesn't necessarily mean that you pull out a highlighter. No, still use whatever you're using. If it's a pen, pen, pencil, pencil. But what we do is we then signify all that range of values. So I'm just going to do it in a different color so that it really jumps out to you. But what we do then is we circle that 3, and I want you to see how I circle it. So I'm going to circle that with an open circle. And now the values where x is greater than 3, we highlight them. Now, by drawing a pencil line over your number line, it doesn't pop. You can't see it. So what we do is we then just draw the line attached to the top of the circle. That shows me that what I want are all the values greater than 3. Okay, to make it very clear on our number line, what we also do is we list out 2 more integers. So what we do is we label an integer to the right of 3, which would be 4, and the integer to the left of 3, which would be 2. What you see in that graph is the graph of x is greater than 3. Nice, not too bad at all. Okay, what I want us to do is do the same thing for b. So we're going to graph that. That means we need our number line. Let's go ahead and put on a number line. I know you guys are all using straight edges to make sure that your number lines are pretty proper. Okay, now I need to put my key value down. So that key value was -1. Most of the time what we'll do now is we'll list the integer on both sides. So 0 would be the integer on one side, -2 would be that on the other. Now what we do is we circle the key value, and now I need to write less than -1. So I need to highlight all the values to the left of that, and there we go. Okay, I want you to take a look at those 2 graphs because there should be a big question popping up in your head. So as you look at those 2 graphs look basically the same. However, I want to draw your attention back up to your solutions. That is, notice that our first one was x is greater than, our second one was less than or equal to. So how do I tell the difference between greater than or less thans and greater than equal to less than or equal tos? Like right now, those graphs look the same. And this is one more of those things that you need to remember. That within mathematical notation, what we do to show when something should be included is we fill in that circle. So you take a look at my graph for B now. That filled in circle tells me that I'm also including that value of -1. Look back at your graph for A, and my open circle tells me that it's everything up to 3, but not including 3. And there you go. In all seriousness, when I said at the very beginning today that there was going to be a couple things you had to consider, remember, adjustments to make, those were the 2. Okay, everything for the rest of the day is basically us just getting comfortable working through that process. Okay, so let's jump in and tackle some more. So let's take a look at problem 3. Problem 3 is giving you the same instructions, solve and graph. Basically, this is going to be us going back to grade 9 for a day. Go through, solve all your inequalities. You can treat them like they're equations, as long as we make that one adjustment for our sign, and we should be good to be able to produce graphs for everything. Okay, so let's start off with A and B, and we'll see if we've got those kind of underneath us. So I want you to pause it, solve both of those at the same time. Okay, go to it. Okay, we're back. So I don't know how you solve the first one. I'm going to solve it just to challenge us the most, maybe. That I'm going to keep that -x on the left side. That means I have to get rid of a +5, so I'm going to -5. Now I'm dividing by a -1. Since I'm dividing by a negative, I need to switch the sign of that inequality. -1 divided by -1, 1. So hopefully we got down to that and we're good. I can now produce my number line. I'm going to try not to slide my iPad around so it makes that big static sound in between. So I put down my key value. There's my 1. I have an integer on both sides, 2 and 0. Now I notice that I'm including the value for 1, so I'm going to put a closed circle. Notice I don't draw a big circle, which then requires me to like really close it in. No, I'll just put a small circle, as long as I make sure that it's clear that it's closed. Don't go and give me something like this. Like now that can be a little misleading. I need values less than, so when I draw on my arrow to highlight those values, I'm highlighting to the left. There we go. Hopefully we match up. If we struggled on that one, then I would probably pause it and attempt B again or make any corrections. Otherwise, we're coming along. So I've got my 2a over 3. I'm probably going to get rid of that plus 4, so let's minus 4. I'm going to probably now, I don't know how we deal with this. Can we do it both in the same step? Let's multiply out our 3 and divide out our 2. So if I multiply out our 3, then I'm going to get a negative 6. Divide that by 2. There's my negative 3. Okay, I've got that. Produce my picture. Like, I'm even so confident that I'm not making silly mechanical mistakes. As I said, this is grade 9 equations, basically, that I don't need to go through the process of checking. You know, if I was sitting to go through on a test, then maybe I'd spend the time to check. I don't know, if I had the time. My key value of negative 3, an integer to the right, an integer to the left. I am not including this value, so I have an open circle, and I'm going off to the right for greater than. There we go. Okay, hopefully those two match up and we're feeling pretty confident and we can see why I said today's going to be a pretty relaxed day. Let's jump into a couple more. Okay, you take a look and you see what's on the screen and you notice they're not really more difficult. It's just more. That I'm hoping that we're not making mistakes working through C and D. So let's do the same thing. Let's use them both as a gauge. Pause the video, solve them both. Okay, go to it. Okay, we're back. So again, this should just be confirmation. I'm going to go through and solve C like I would solve C. I like positive coefficients. So I'm going to imagine my x's being on the right. So I'm going to have 5x minus 3x. There's 2x. That means that if those are on the right, there's my inequality symbol. Now, just confirm that you have that if you did the same thing. But that's the way I'm going to solve that. So that now I can imagine my constant going to the other side. And so I would have my negative 4. Just notice, this is what you would have had. And we can see that those two are the same statement. Okay, now I can go and I can divide out. And the nice part about dealing with positive coefficient, I put in a little bit of thought early so that I don't even have to worry about changing the sign of my inequality. Had you dealt with it the other way, then yeah, we're going to probably have to deal with changing the sign. Okay, x is less than 2. So, my number line, put on your key value, put on an integer on both sides, and now, open circle, less than. Okay, let's take a look at D. And D just means we've got, I don't know, more things to expand, collect. Risk for error is greater, but as I said, it's not more difficult. I'm hoping we didn't put that 4 and 2 together and broke bed mass. We're probably going to spend a line, possibly, just simplifying each side. And now I can go through and solve. Same thing, positive coefficient would be on the right side. So I get 5x is now less than or equal to 7, and so x is less than or equal to 7/5. Okay, number line. Now, this is what always drives me nuts, is that some people put in their mind this idea of, okay, so I put on my key value, and now I put a value to the right and to the left. And so I'm going to bet that some of you have this, 8/5, 6/5. Don't you dare have that. Listen carefully to what I said. We put down the integer that exists on the right and the left. So if I look at 7/5, 7/5 is 1 point something. Like, who even cares about what the point something means? It's 1 point something. So the integer to the right is 2, and the integer to the left is 1. Now I can go ahead and mark it. It's less than or equal to, I'm including it, so I have a close circle, and I'm going to the left. There we go. So, as I said, hopefully we match up and we're dealing with things pretty well. Okay, we got one more problem. That's it. Here we go. Okay, so, yeah, you said you had one problem left, and now you see the screen, you got two. But I just want you to take a look at both those problems. And I want you to notice I only made one change between them. Notice that the denominator in question F, the second fraction is negative, where I gave you the positive one in the first case. So I'm going to argue really what we're going to talk about is E and F combined. We're actually going to use E as a bit of a check on F. So I want you to pause the video, and I want you to go through and just solve E, but let's use E as our gauge. Do we have a decent grasp? And I would argue you really have everything you need at your disposal if you can go through and solve E correctly. Okay, so just E, let's leave F for a moment. Okay, pause it now. Okay, we're back. So pretty quickly, I would hope that most people would look at that and say, well, to get rid of my divide by 3, I'm going to multiply by 3, divide by 4, multiply by 4. So we're coming in maybe on this as a first line that we're just going to cross multiply. And now you turned it into something that we're pretty decent with. I get x is greater than or equal to negative 22. I'm not even going to worry about the graph portion of that for right now, but there's my solution. Nice. If you got down to that, you're good. You're good. Okay, now what I want you to do is tackle F. So work your way through, solve F. Pause the video now. Okay, we're back. So I'm going to expect that I would have a lot of people that would do this. Well then, why don't I cross multiply as well? So negative 4x minus 16 greater than or equal to my 3x minus 6. Now I have a 7x on that side, and I'm just going to write it so that we're totally like crystal clear. Now I have my minus 10 on the other side, so maybe now I can flip it and feel a little more comfortable. All I'm doing is changing my direction, so x is less than or equal to my negative 10 sevenths. Now, we could go through and do a left side, right side check, but I'm going to help you out in this instance. Let's go super fast. X is less than or equal to negative 10 sevenths. Pick a value that we think works. The easiest value, since that would be like negative 1 and a bit, would be to pick negative 2, because we're less than or equal to. So I'm going to pick negative 2. And on that left side, I'm going to get 2/3. On the right side, I'm going to get negative 2 minus 2, which is negative 4 over negative 4. That's a positive 1. Well, I just want to draw your attention. Okay, clearly the left side is not greater than the right side. So we goofed up. Okay, what's the issue? What went wrong? Well, take a look back at the problems again and see what adjustment I made in the problem. Remember, I switched the sign of that denominator on the right side. Now, it shouldn't surprise us that that's going to give us a different value. So the fact that we got negative 10 sevenths isn't the issue. It's that when we cross multiplied, maybe we didn't really see what we were doing. So what I'm going to do is I'm going to get rid of that whole blue solution. I'm actually going to get rid of all the blue I've even written down there. And what I want to do is I want to walk through this problem a couple different ways. Okay, technically, this is what we do when we cross multiply. Sometimes I think we forget this, that even though we're shown when we're younger, sometimes I think we forget that we're still going back to the scale analogy of an equation. That is that as long as I do the same thing to both sides, my equation stays balanced. That technically what we do is we multiply both sides of this by negative 12, the product of those two denominators. It's just that you don't ever do that because you very quickly say, Well, negative 12 divided by negative 3 is a negative 4, and negative 12 divided by negative 4 is a positive 3. And so it just looks like all we ever did was cross multiply. But really what we did was the green. And I hope that you can see that if I really did the green, then I just multiplied both sides of my inequality by a negative value. That means I should have changed my inequality symbol. There's that little piece of theory again. But for some of us, we're going to miss that. Now, I am hoping that if I just get rid of that blue again, and I'm going to get rid of everything in the problem, that even my act right here of multiplying out my negative is going to get me to change the sign of the inequality. However, what if that 3 was also negative? Then are we going to consider that when I multiply one by the negative and multiply the other one by the negative, then really I either changed my inequality twice so it didn't move, or I really just multiplied by a positive so it doesn't change? That for some of us, going through and cross-multiplying can cause a problem if either of those denominators happen to be negative values. So if we are really on the ball, then I would expect to see this solution. We're going to multiply by negative 4. Oh, I just multiplied by negative. Change the sign. And now we can solve that pretty quickly. Okay, 7x, negative 10. So x is greater than negative 10 sevenths, and we're good. That's a solution I would expect to see if we're really aware of that concept of dealing with changing the sign of the inequality. However, if you're somebody who just knows, okay, I know I'm going to goof up on that, that's what I'm going to forget, I know I'm going to do it, then if I can offer up another way to deal with it. Let's go back to some of that theory again. That just remember, if you have a fraction where your denominator is negative, you can move that across the fraction line. Apply it to the numerator. 6 divided by negative 2 is the same as negative 6 divided by 2. A positive divided by a negative is the same as a negative divided by a positive. And so what we could do within the problem is instead manipulate the problem. That what I could have is this. I'm going to move that negative across and then just make sure that I apply it to all parts of the top. Because in this instance, now I can freely cross multiply with no concern over the sign of the inequality. Okay, I can get my x's on the left side, I can get my constants on the other, and when I divide out, we match up and we're good. Okay, it's something to consider. You've got two options. Move that negative up to the numerator and apply it there, or be very conscious and make sure that we switch the sign of the inequality. Okay, the only thing left to do for both these problems is just graph them. So let's do it super, super fast. I used up my blue on that one solution, so I'm switching my number lines to green. I'm going to put on both number lines like right away while I've got my ruler out, and hopefully that minimizes the sliding sound. Okay, I've got my key value of negative 22, one value that's greater, one value that's less. I now need to go through and put on a closed circle at negative and greater. And within my second graph, I would now have, I need my green, a negative 10 sevenths. I need my integer to the right. So negative 10 sevenths is negative 1 and a bit. So that means I would have my negative 1, my negative 2. I now need to highlight with an open circle everything greater. And there we go. So hopefully everything matched up. And we found today to be pretty straightforward. hopefully a little interesting, that we took something that is a pretty decent background skill, inequalities, and we were able to kind of work our way through and see how we can apply it with some of our algebra. Okay, jump in, knock out some practice. Good luck.